Okay, this video is going to be looking at question 7, part 2 of the June 2014 Edexcel paper, FP1 paper. And the question says, the triangle T has vertices at the points 1k, 3, 0 and 11, 0, where k is just some constant. Triangle T is transformed onto the triangle T dash by this matrix, 6 minus 2, 1, 2. So, given that the area of the triangle T dash is 364 square units, so D dash, remember, is the new triangle, so the triangle which has been transformed by this transformation matrix, and its area is 364 square units, find the value of k. Okay, now this question relies on you understanding what the relationship is between transformation matrices and, more specifically, determinants of transformation matrices. Okay, so I'm going to try and hopefully build up a little bit of intuition before I just jump straight into answering this question, because it shouldn't be, you can just remember what the determinant of a transformation matrix is, but I'm going to try and hopefully build up a little bit of intuition first, because I'm not one of these people that likes remembering the question. Oh yeah, and just likes remembering methods. And by the way, this question is worth 6 marks, okay? So if you're looking at it and you're thinking, do you know what, I might just write it off, I would never ever recommend that you do that, because actually when you see how it's done, it's really easy and really straightforward. And particularly if you've got a little bit of intuition about why it's not hard intuition, particularly if you've got the intuition, they're nice, generous 6 marks, okay? But yeah, it does require a little bit of further thinking. Okay, well, let's first of all start off with thinking about what transformations actually are. So let's just look at a one-dimensional case. Let's say we have a point X, okay, and we perform a transformation on it, A. Okay, so X basically goes to AX, okay, and the A is our transformation, okay. It basically acts as a scale factor. Now, scale factor, what's that? Okay, scale factor is just simply how many times bigger or smaller something is. Okay, it's literally just a multiplier. So if you multiply by, say, like 2, then everything becomes 2 times bigger. But if you multiply by half, everything becomes like a half bigger or 2 times smaller. Okay, so A is just simply acting as a scale factor. Right, so this is the one-dimensional case. It's just simply saying that the point X ends up A times further away than where it started. So it's just simply dealing with length. Okay. Now let's look at a two. If you look at it, the A as a matrix. Okay, that is possible. You're just looking at it as a 1 by 1 matrix. So A is just a matrix 1 by 1. Okay, it's 1 row, 1 column. Then the determinant of that is going to be A. Okay, so we're already building up the kind of idea that perhaps determinant is linked to scale factor, because we've said that the scale factor is A, and the determinant of A is the scale factor. Okay, so maybe, we're already building on that idea. Now let's look at the two-dimensional case and see if our kind of idea about the determinant of a transformation matrix does match up, that it is the scale factor. Well, let's look at this one. Let's say we have a point xy. Okay, two-dimensional point now, because we're dealing with 2 by 2 matrix, so it's two-dimensional point. And we multiply by a transformation matrix, I don't know, let's say 2, 0, 0, 2. Okay, well, if we multiply this out, we'll get 2x, 2y. So we can also just take out, because there's a 2 common to both elements in here, so we can just take a 2 out the front, just as a multiplier. So we can basically say that xy, the point xy, we'd perform the transformation matrix on it, and it ends up 2 times further away than where it started. So the scale factor in this case is 2. So in other words, the length, we're dealing with length, it ends up 2 times further away. Now let's work out the determinant. Let's just verify that the determinant is the scale factor. So determinant of 2, 0, 0, 2. This is sometimes written as, rather than writing det all the time, we sometimes just write it as straight brackets. Okay, it literally means determinant. Okay, modulus, if you like, of a matrix is, with these modulus signs, that's the determinant. Okay, well, let's work it out. It's going to be 2 times 2. So it's the leading diagonal multiplied together. Subtract the elements on the other diagonal. multiplied together. So subtract 0 times 0. Well, 2 times 2, of course, is just 4. And 0 times 0 is 0. So it's 4 minus 0, which is, of course, just 4. But hang on a minute. We just said that the scale factor of the transformation matrix is 2. It basically ends up 2 times further away. So if the determinant, so our original thought was that the determinant of the transformation matrix was just the scale factor. But if that was the case, then this number should be 2, not 4. So what's going on? Because determinant is linked to scale factor, just not necessarily linked to the length of scale factor. Well, let's draw our coordinates out. Okay, so let's say we have x and y. So this length here is x. This length here is y. Okay, and we can form any shape we like, but I'm just going to form a square, just for a rectangle, just for completeness. Okay, and then we perform our transformation. Okay, and we end up with something that ends up 2 times, so 2x and 2y. So it ends up being 2 times as big. Our shape ends up, the length on both our sides of our shapes end up being twice as big. So we end up with 2x and 2y. Okay, so this is 2x and this is 2y. 2y. Right? But look at the area of this new shape. As you can see, we've got 1, 2, 3, 4 times as big. Okay? Well, we've just said that the determinant of our transformation matrix is 4. So suddenly, we got it wrong in the first instance. We got it right in the sense that the determinant of our transformation matrix was a scale factor, but the determinant of the transformation matrix is the scale factor of the area as opposed to the length. Okay? So the area, the new area ends up being 4 times as big. So basically, when we find the determinant of the transformation matrix, that just corresponds to how many times bigger or smaller the area of the new shape should be. So the scale factor of the new shape. Okay. So now we can use that in answering part 2 of the question. So triangle has vertices at these points. I always recommend drawing the shape. Okay. So I'll write the points out again. We've got 1k. We've got 3, 0. And we've got 11, 0. Okay, so let's draw that. Very crude, rough diagram. So say this is 1, this is k. Let's say this is 3, like I say, that is not, yeah. And then let's say over here is 11 somewhere. Okay, so 3, 0, 11, 0, so these are our points. And it forms a triangle. Now remember that k can also be negative, so it doesn't necessarily have to be up here, it could also be down here, say. This is negative k. Well, this k could be down here, so we could also have a shape that looks something like that. Okay, so that's just something to bear in mind when we get a final answer for k. It could be positive or negative. Okay, so what's the area of this triangle? Well, it's half the base times the height. So it's area of triangle T, this is T. Area of triangle T is equal to half the base. Well, the base is going to be 11 minus 3. It's going to be this distance here times the height. Well, the height is just going to be k, isn't it? It's that height there times k. So what's that? Well, it's going to be half times by 11 minus 3, which is 8, times k. So half of 8 is 4, so it's going to be 4k. So the area of triangle T is k. Okay, well, we've been told in the question that the area of triangle T dash, so the area of our new triangle after transformation, is equal to 364 units. Now we know, we've been told the transformation matrix. The transformation matrix is 6 minus 2, 1, 2. Let me just double check that is the right one. Yeah, 6 minus 2, 1, 2. Just let me sort that out. There we go. So we got 6 minus 2, 1, 2. So that is our transformation matrix. We know that the determinant of the transformation matrix links the area of the old triangle, to the original triangle, to the area of the new triangle. That tells us the scale factor. So if we find the determinant of this thing, that will tell us how many times bigger or smaller this thing should be compared to this. No, wait. I got that the wrong way around, I do apologise. How many times bigger or smaller this thing should be compared to this. So in other words, when we multiply the determinant of the transformation matrix by this, we should end up with this. Okay, so let's work out the determinant of this thing. It's going to be 6 times 2, remember the leading diagonals multiplied together, minus the other elements on the other diagonal to multiply together, so minus 2 times 1. Okay, and that should be 6 times 2 is 12, minus 2, double negative, 12 plus 2. That's equal to 14. So basically our scale factor of area should be 14. So in other words, this 364 should be 14 times bigger than 4K. So 4K is the original area of the triangle T. Area of T. We then multiply by 14 and we should get the area of triangle T dash to be 364. So basically, if we divide 364 by 14, we should get back to our 4K. Okay, remember the aim of the question, we want to find what K is. So, divide 364 by 14, that, in my head, that's 26. 4K. Okay, so that then implies that K should be, well, if 4K is 26, then K should be 26 divided by 4, shouldn't it? So that's 13 over 2. Okay, and that's the value of K. But remember that K could also be negative. So it could be 13 over 2, but it could also be down here as well. There's no reason why it can't be. So K can equal positive or minus 13 over 2. Positive or negative 13 over 2. Right. Where are the marks for that question then? So there's 1 mark for showing that the knowledge that the area of the triangle is given by this formula. Okay, so it basically means that you've drawn the shape, you've understand where everything should be. Okay, and you've used that to try and find the area of triangle T. So even if you don't get the right numbers in the right place, you still get 1 mark for trying to attempt finding the area. Okay, you also get 1 mark for finding that the area is 4K. So there's a method mark and then there's the answer mark. Okay. Then you want the method of the area of the determinant. That's another mark, so showing that you've got the right method. Then there's another mark for getting the right number. Okay, so that's 2 marks. A full mark, sorry, altogether. Then there's finally a 5th mark for showing this thing. Basically, your knowledge that the area of the determinant links the scale factor area. Okay, so even if you get, say for example, if you got it the wrong way round, so saying that 364 times 14 is 4K, so you're getting it the wrong way round, even though it's wrong, knowing that you've linked the two things together, knowing that the 14 is the scale factor of the areas, you get another mark for showing that knowledge, and then of course you get the final answer there. If you didn't put plus or minus in the exam, if it was you answering the question, if you've got the plus or minus, they would have been fine with that. They still would have given you the first full marks. If you just put 13 over 2, they wouldn't have been picky like that, even though it is strictly positive or negative. Or even if you put K equals minus 13, so you 13 over 2. So even if you drew it wrongly originally, so you just, instead of just using the positive one, like most people would have done, if you use the negative one instead, that would have been fine. Basically, all they're looking for is 13 over 2. Okay, they would have given you the mark for any one of those.